1.5. Methods-driven results. This section describes how one's approach can influence the results of scientific investigations. To illustrate this, we use the parable of a fisherman who discovered that all fish are larger than 5 centimeters and have gills, but the scientist explained to him that this was the mesh size of the fishing net and not the actual basic characteristics of fish. We apply this simile to science to show that measurement methods and their capabilities can have a discernible impact on our results. We always investigate with defined measurement and evaluation criteria, which inevitably determine our results. What we have not measured or analyzed is not available to us as a result, but perhaps it is precisely these results, often data, that we need to explain or solve a problem. The former director of the Max Planck Institute in Munich, Hans-Peter Dürr, made it clear to me in a fascinating interview about his approach and his results how much it is precisely one's approach that determines the results. He meant by this that the reality of the natural scientist is what appears to him, but not the real reality of nature. The parable by Hans-Peter Dürr. Dürr uses a parable of a fisherman, who, based on his personal experience of fishing for many years, came to 2 basic laws of fishing. First, all fish are larger than 5 centimeters, and second, all fish have gills. The fisherman simply called both of them basic laws, because these facts had been confirmed with every catch, so that he could assume that it would always be this way in the future. Then the fisherman met the philosopher, who told him that the 5-centimeter statement was certainly not a basic law. The mesh size of the net rather determined that smaller fish could not be caught. But that did not impress the fisherman. He said, what he could not catch with his net is not a fish to him. The application on science. Hans-Peter Dürr transfers this parable to the natural sciences, which in his opinion also always claim that they have found something and that what they have found is a property of nature, and not rather a property that nature reveals to them, through their measuring methods and so on. So, in this case, the mesh size of the net determined what could be caught and thus declared and examined as a fish. The measuring method and its possibilities have recognizable effects on the result, and to a considerable extent, as the parable makes clear. More generally spoken, we always investigate with criteria of measuring and judging, which, however, actually predetermine our results. For what we have not measured or analyzed is not available to us as a result, and perhaps it would be these very results, often data, that we need to explain or solve a problem. Our temptation to any generalization. On the basis of the data obtained, we quickly get carried away with generalizations. Then the laws of logic are invoked, for example, like this: since we are dealing here, as so often, with a fundamental problem for which we now have data and can design a solution, we may draw this or that general conclusion from it. Are we really allowed to do so? Skepticism is the order of the day, and that is exactly what Hans-Peter Dürr encouraged us to do, because his fisherman had invented the universally valid basic law of fishing, according to which fish are always at least 5 centimeters long, solely on the basis of the mesh size of his net. Meanwhile, the fisherman's neighbor and competitor may be casting a net whose meshes are 8 centimeters long. His basic law would therefore be that fish are always at least 8 centimeters long. Interdisciplinary working. When the natural scientist Hans-Peter Dürr has the story of the fishing net and its meshes in mind, it is the physicist who is talking to us. He measures and determines his result from data, all the way to the law of nature. Other sciences proceed differently. In the humanities, for example, logic, plausibility, and understanding are part of the scientist's necessary tools. In the social sciences, for example, it is a matter of statistically and empirically gained and deepened knowledge about relationships. And when the methods of one's own discipline are sometimes not sufficient, scientists also go beyond their boundaries and conduct interdisciplinary research. They then build phases into their projects in which they make fruitful use of the instruments of other disciplines. Thus, empirical methods of the social sciences are often used by other disciplines to support the respective hypothesis or theory formation or to test the suitability and validity of a thesis for everyday life. Learning from each other. The encounter with Hans-Peter Dürr motivated me a lot for my own research. That was in 1997, when he was still director at the Max Planck Institute in Munich and had previously been an assistant to Werner Heisenberg. As an astrophysicist, he looked very methodically at everything that is, or appears to be, there and moving. I came from the humanities, he was a natural scientist. I was with him with my camera team to record statements for my TV documentary series, From Stardust, Man in the Cosmos. At the beginning of the filming, I still suspected that everything was in motion, especially in my humanities, that there were constantly new impulses, even philosophical schools, but not in the natural sciences. But Hans-Peter Durr made it clear to me that we are all always guided, indeed determined, by the framework conditions in our thoughts, actions, and results. So whatever our result will be, it will also be your result. Our result is inevitably determined by the methods we use.